Hi all, this is B. Ramesh, working as Assistant Professor in the Department of Artificial Intelligence and Machine Learning from St. Martin Engineering College. I welcome today online class. The class topics are what is meant by the compiler and what are the various phases of the compiler. Now let us define how we can define the compiler is, right? Now what is meant by the compiler means, so generally if you want to define compiler, so compiler is nothing but it is a software. It is a software. It translates from one language to. So this is one language. So which is called as source language, and from source language to it converts from machine language, or which is also called as machine code. Now while we convert from source language to machine language or machine code, there are various phases we had various phases we had. So the phases are lexical analyzer, syntax analyzer, semantic analyzer, and then intermediate code generation. After that we had code optimization, and finally code generation. So these are the various phases of the compiler. In general, how we can define once again compiler is, so it is a translator. It translates from one language to another language. Between these process we have these kinds of phases are there. Now move for a small program, so that is called as one high level language I have to take in here. So that is, so for example, hash include stdio.h, stdio.h. So this is one line which is also called as one statement here, and then we need to start the main function here. Main function started here, and after that I declare the variables. So the type is integer here, and variables are a comma b comma c, and then I have to print that values. So for that I have to write the printf statement here. So that means enter two values, enter a comma b values. So printf statement clear here, clear, and then I have to print the values of that a comma b. For that I need to write percentage d and percentage d. After that I need to store the address of that variables a comma b. So for that ampersand a comma ampersand b, and then I need to calculate the mathematical function, that is c equal to a plus b. So this is the function, and then I need to print the resultant value, that means percentage d and c, and finally return 0. So generally this is the one kind of small program. So this is the C program. So this C program, which is also called as high level language code only. Now let us try to understand one more point. So this is the statement 1, and this is the statement 2, and this is the statement 3, right? And this is the statement 4, and statement 5, statement 6, up to statement 9. So these are the various kinds of statements we can call it. So all kinds of statements we can put into one place. So that is called a sample program, so which is also called as a software. Now we can understand, so we can easily understand this is a source program. Then whenever we give this source program to the compiler, that compiler how this source program converted into machine code in between. So in between these phases, so all the things will done by the internally by this compiler. Now let us move for what are the how the each phase will be work. How the each phase will be work we can see. Now first we can go to this compiler. So the first phase is the lexical analyzer. Now what the lexical analyzer does? So what the lexical analyzer does means, we can see here. This is the one sample page, right? Now we can see here, this is the lexical how the compiler will be work. Now we can see this is the Java source code, we can call it as this is the simple source code only. Now whenever source code given to this compiler, then compiler converts this source code into the machine code, and finally it give to the output. So this is the how the compiler works. Now whenever you go for the interpreter, so interpreter takes the source code only, and never this interpreter never converts the source code into the machine code. It can directly give to the output only. So for that there is a small differences between this compiler and the interpreter. Now we can see here, so how the compiler, so here translate the compiler, so we can see translate the entire program into a single line. So that means it can convert the entire program into a once. So that is called the compiler. Whenever you go for this one, so whenever you go for this interpreter, so this interpreter translate and executes the complete code line by line only. Now this is the one small differences between the compiler and the translator. Now whenever you can go to this compiler, compiler automatically generates the mission code only. Now whereas this interpreter, so it never produce any mission code. And again you can see, so these are the some sample compilers. You can see this is the some GCC, so which is called as GNU compiler collection or Clang. So these are the compilers, we can call the examples of the compiler. Now we can go look onto the interpreter. The interpreter examples are the Python and the Ruby are the examples for the interpreter. Now you can compare this compiler and interpreter. So this compiler is a faster execution time. Now when you go for this interpreter, so it is the slower execution of the time only. Now this is the major differences between the compiler and the interpreter. So you can see once again here, and this is the procedure of how the compiler works and how this interpreter works. Now we can see after these things, now what are the phases? So what are the phases were presented from source code to from mission code. So these are the phases we had. So one is lexical analyzer is the first phase, and second one is the syntax analyzer, and after that semantic analysis, and then intermediate code generation, code optimization, and finally code generation. So after taking all the inputs from the previous phases of the code generation, the code generation will generate the mission code only. In between these phases we had another two topics we had. So one is symbol table and the other thing is error handler, means so we can get some identifiers, so which we can store in the symbol table later, and whenever we got some different kinds of error, that will be handled by the this error handler. Now let us try to understand each phase in the compiler. Now first one is the lexical analysis. So the lexical analysis is, so this is the first phase of the compiler. This is the first phase of the compiler. Now what is the role of this compiler is, it converts the source code into a stream of tokens. So it takes all the source code, whatever the C program and whatever the Java program we have written as the high level language, so that should be taken by this lexical analysis, and after that taken off that source code, it will be generate some stream of tokens. It should be generated by the stream of tokens here. Now what is meant by the token? What is meant by the token is, so the smallest unit of the meaning is called a token. So smallest unit of the meaning is called as the token. Now we can see some examples. So whatever the keywords were presented in the source code, so that is called as the keywords, or otherwise whatever the operators we can use in that source code, so we can call as the token only, and whatever the identifiers we can use in the source code, that should be treated as the tokens only. Now what kind of tools we are used here and what kind of tools we use in this lexical analysis is, so lexical analyzer, so which is called as the Lexer or Lexeme we can call, that is the tool we can use, and we can generate the stream of tokens in the lexical phases. Now you can see some example. So for example, this is the integer a equal to 5. So this is integer a equal to 5. So in this integer a equal to 5, we can see this is the one data type. So that should be understood by the C language only. Now a is a small variable, so which is stored some value here, and you can see here equal to is some equal operator in C language we can use, and later so 5 is a small number we can use it to find out or else calculate the various calculations. Now what are the tokens generated by this lexical analysis? By this integer a equal to 5 statement. Now in this, integer is a one kind of token here, and a is another token, and equal to is another token, and 5 is another token, and after that we had special symbols, that is the semicolon. So all these are called as tokens. So means, coming to this lexical analysis, once again, lexical analysis taken the complete code from the source code and it generates the stream of tokens here, and after that, so by using how we can partition the source code into various kinds of the tokens. So this is the operation done by the lexical analysis. Now we can move to the next phase, so that is called as syntax analysis. Now what is the syntax analysis? So whatever the output generated by the lexical analysis means, all the tokens will be given to this syntax analysis as the input only. Now means, analyze the all the tokens. So whatever the output was generated by the lexical analysis, it should be taken as the input to the syntax analysis, and then so it develops or it makes some parse tree. So syntax analysis does a grammatical structure. So after checking the grammatical structures of each tokens, so it should be developed one parse tree. We can call it as parse tree. Now what kind of tool we use in this syntax analysis is, so parser we can use it. So by using this parser, we can develop a parse tree. Now example for this syntax analysis output as the abstract syntax tree. Abstract syntax tree is a one kind of parse tree, so which is developed by this syntax analysis. Now what are the inputs of this syntax analysis is, so whatever the tokens were generated by the lexical phase, that should be taken as input and finally generated a small parse tree, or which is also called a parse tree, with the help of some parser tool. We can observe one small example here. So means, you can see here the expression. So for example, parsing expression is a plus b star c, right? A plus b star c, this is a one kind of expression. Now from that expression, so we can generate one parse tree or graphical representation of that expression. Means, so we can develop, so this is a small diagram or small diagrammatical representation of the previous one. So this is nothing but a parse tree. Now where parse tree we will get is, so in the syntax analysis we will get the parse tree. Now this is the diagram. So means, source program we got here and we will give to lexical analyzer, and after that, so from here to tokens are generated by the lexical analyzer, and then so all the tokens will give to this parser only, and after that parse tree, so we will get some parse tree representation. Now let us move for the another phase, that is the third phase. So the third phase is the semantic analysis only. So in the previous phase, so we got parse tree. So after getting the parse tree, so we will go for the semantic analysis. So in this phase what we do is, so we can check whether the parse tree is perfect or not. So whether the parse tree was accurate or not. So means, we can see what is the role of the semantic analysis, so ensure the semantic consistency and the correctness of that parse tree. So whether the parse tree is a meaningful or not, this should be checked by the semantic analysis only. Now what are the conditions will be checked by this semantic analysis is, so one is type checking, and second one is the scope resolution, and third one is the array bound checking. So all these kinds of checks will be checked by the, so whether the parse tree is a meaningful or not. If the parse tree is meaningful, then we can directly give to intermediate code generation. Now what is the example for this semantic analysis is ensuring variable types of matches in the assignments. So ensuring whether the variable types match in assignments or not, that should be developed or that should be done by this semantic analysis only. Now later we can see the fourth phase. The fourth phase is the intermediate code generation only. So this is the fourth phase of that compiler only. Now after we will get after these things, we can see here the what that means. So what is the role? So what is the role of this intermediate code generation is, so translate the syntax tree into the intermediate code generation. So translate the complete syntax tree into intermediate code generation only. Now why we have to go for this intermediate code form means, so whether the platform independent of the code representation only. So that is the thing. So for example, you can see the parse tree will be converted in the form of this code format. That means A equal to P plus C. So this is the fourth phase of the compiler only. Now we can see another one is the code optimization. Now what is meant by the code optimization? So what is meant by the code optimization is, so it improves the intermediate code to make it more efficient. So if you want to make the more efficient of that code, so we have to go for the code optimization. Now what are the various kinds of techniques we are using in this code optimization is, so we can use some constant folding, we can use some deadlock elimination or dead code elimination, and later we can also use some loop optimization. So by using these techniques, so we can improve the intermediate code to make it more efficient. So for this is the purpose of the code optimization. Now what is the final goal of this code optimization is to reduce the execution time, to reduce the execution of the time and the resource usage. So for that purpose, so we have to go for the code optimization. And after that code optimization, and next later, so we can see the last phase, so that is the code generation. So what is the purpose of this code generation is, so to convert the optimized code. So in the previous phase, so what we got is, so each and every code was optimized. So by taking the input as that optimized code to this code generator, so this should be developed, or this should generate the mission code only. This the code generation which converts the complete intermediate code into mission code. Now what is the output of this code generation? So what is the output of this code generation is, so it can generate either assembly code, or it can also develop, or it can also generate either that is the mission code only. So this is the some sample output of that code generator. Now what is the example for this code generator is, so generating a mission code or for the arithmetic operations. Now we can see once again here, so in the previous code optimization we had, so means each and every code, whatever the codes were generated by the intermediate code generator, so from the code optimization each and every code will be optimized. So after that optimized of that code, so given to the input as this code generation, so this code generation will convert that optimized code into the, whether it is maybe mission code or otherwise assembly code. Now we can see the example generating the mission code for the arithmetic operations. So whenever we want to perform any arithmetic operations or the relational operators or logical operators, so we want to generate that mission code. Then how these kinds of mission codes will be generated by the compiler is, so this is the code generation of the last phase, we can use it. So from the among that all the phases, so from the among the all phases, from the lexical analyzer to code generation, so the source code will be generated to the mission code only. Now what are the various compiler construction tools we can use, right? What are the various compiler construction tools we can use in a nowadays means, so you can see Lex tool is one of the best one. So Lex tool is one of the best one. So this tool for the lexical analysis, so this is the first phase, already we know that in the lexical analysis, so we have to use the Lex tool. So that is the one compiler construction tool only. And second one is, so next another compiler or another tool is YAC or Bison and tools for the syntax analysis. So in the lexical analysis we use this Lex tool, and when you go for the syntax analysis we can use this YAC tool or Bison tool. And when you go for this compiler infrastructure, to know the infrastructure of the compiler, so we have to use some LLVM compiler, LLVM tool. And another thing is, so GCC, that means GNU compiler collection. So GNU compiler collection is used various kinds of or higher various kinds of languages compilers where we can gather and put into one place. And later other tools are ANTLR and FLEX are the various kinds of tools we can use. So these are the various phases and how the compilers, so how the compilers we can use, and how from the lexical analysis to code generation, how the each and every code will be generated. Now we can go for this program, right? Now we can see here, so this is the high level language codes, so we can write into in C language, so this should be understandable by the human. But when you look onto the computer, so computer can never understand or can never understand this kind of high level language. Now, so what the compiler does means, so this complete high level language code, this complete high level language code converts into so mission level language. So high level language to mission level language. So whatever the various statements we have written, so this should be converted into mission level language. Means, so in the preprocessor stage, so whatever the special symbols, some hash symbol we had and predefined statement, that is stdio dot h, so this should be eliminated by the lexical prefacer phrase. So before of that lexical analysis, and after that, so when you go for the lexical analysis, so the complete statement will be partitioned into like as same main and parenthesis and open braces and integer a comma b comma c. So means each and every variable, each and every type or each and every identifier, so will be partitioned from the lexical analysis, and after that it will be given to the syntax analysis. Means the tokens will be treated as the parse tree, and after that semantic analysis we can make whether the parse tree is meaningful or not, and then we can make some intermediate code formats there, and after that intermediate code formats, so we have to move for the to optimize the code for that. So we have to go for the code optimization, and finally after optimizing the code, so we try to move for the code generation, and finally we will get some mission code. So mission code completely in the form of the zeros and ones format only. Means, so here only the computer understand zeros and ones format only. Means all this language, all this high level language, so will be converted into in the form of zeros and ones format. So for that the compiler will follows all the phases, right? And by using these compilers, various kinds of the compilers we can use it and convert, definitely we can convert the mission code too. Now let us try to understand once again. So we can see here we can go for this one. So after getting the mission code, now we can also observe one point here. So that is the interpreter, what the interpreter does. What the interpreter does means, so look onto here. So this is the one small program we have written already, right? So already we have written some program here. So by using the compiler, so we can observe, see all the zeros and ones format we can got it here. So this is the way how the compiler, the complete language, the complete high level language convert into mission code, right? Now we can see some again once again the differences the small definition between the compiler and the interpreter. So compiler and the interpreter, so we can see here, so this is the, it translate the entire program once only. So means whatever the programs, how many lines we had, for example we have 50 lines of code, that 50 lines of code will be executed by the at a time only. So that should be treated as the compiler. Now when you go for the interpreter, so it compiles each and every line what once only. Means translates and executes the each and every code or statement line by line only. So that is the interpreter. Now when we go for this compiler, so it generates the mission code. So mission code should be generated by the compiler only, and when you go for the interpreter, so interpreter never produce any mission code here. So that is the major differences between. Now once again you can see the compiler will, it should be takes a lesser time, which is also called it executes the fast, and when you go for this interpreter, so it interprets or it executes the slowly only. Now you can see the major differences between the compiler and the interpreter. So here, so this is the Java language or C language we have written. So in the form of source code, we can give to this compiler and it should be generated by the mission code, and finally we will get some output, and later you can see the how the interpreter works. So means we can write some JavaScripts here, so it should be treated as the source code only, and then so it should be give to the interpreter, and finally we will get the output here. So this is the how the compiler works and as well as how the interpreter will be works. Now later we can understand, so by using some video, how the compiler phases will be work. Now let us move for this small example for how the compiler will be executes from the lexical analysis to the code optimization. We can see here, so that is how the compiler will be work. Now this is the some sample video, we can understand how the compiler will be work, right? Now look onto here, so this is the compiler, right? So this is the first phase, you can see here, this is the, so we can write once again, so you can see, means we can write some source language here. So after getting the source language, so we have to give to this lexical analysis, means you can observe here, so this is the lexical analyzer, all the code, whatever the code we have written, so whether in C language, whether in Java language, or whether whatever the language it is, so it should be given to this lexical analysis. So after getting the lexical analysis, so we have to give to the syntax analysis. So in this syntax analysis, so we should develop some parse tree. So after getting the parse tree, so that should be given to the semantic analysis. So in the semantic analysis phase, so we can check whether the parse tree is or not. And later you can also observe, so after the parse tree, we have to go for the intermediate code generation. So in this intermediate code generation, so we will get all the different kinds of intermediate codes. Right here in these phases, intermediate codes we will get it, right? And after getting the intermediate forms here, and we have to give to this code optimization. So here all the code will be optimized and later it should be given to this code generator. Finally, after getting these things to the code generator, so we will get some mission code here, right? So this is the how the phases, how the compiler phases will be work, right? From the source code to from the code generator, how the phases, each phases compiler will be work. So meanwhile we had some symbol table now where we can store the each and every identifier there, and later meanwhile whatever the errors we will get, so that should be handled by this error handler. Now we can see all these phases with a small example. Now this is one example we have written. Now sum equal to old sum plus rate into star 50. So this is the code we have given to this lexical analyzer, and after getting the lexical analyzer of that code, this should be given to this syntax analyzer. So means it should be converted in the form of tokens, that is id1 equal to id2 plus id3 into some id4. So this should be treated as the tokens and given to this syntax analyzer. After taking of these things, so it should be generated some parse tree. So this is the parse tree we had generated by this syntax analyzer. So this is the graphical representation of the code what we get from the lexical analyzer. Now we want to check whether the graph is meaningful or not. So for that we have to go for the semantic analyzer. So this is the semantic analyzer, whether the graph is a meaningful or not. So after these things, so this should be, we have to develop some intermediate code forms. So for that intermediate code forms, from the meaning, whether the graph is meaningful or not, from here to here, so means we had some intermediate code forms, and then after getting the intermediate code forms, so we have to check whether we have to optimize the code. So for that, so we have to take that code optimization and optimize the code, and finally, so after getting the optimization code, the code generator will convert the code optimization code values to this machine level language. So this is the machine level language, that means, so whatever it should be in the form of zeros and ones format only. Now we can see here, so this is the complete Java program or C program we had. So by using this compiler, each and every phase will be converted into machine level language. So like this, the compiler will convert from one language to another language. So this is the how the compiler will be works from all the phases of the phases. Right? Now we can observe from this hello.world.c. So this is the machine level language. So which is all is in the form of the zeros and ones format only. So this is the today's session. So thank you very much.